Group time of death. For group time of death, we divide the time continuum into indefinite number of fixed interval of equal length. It is not important to have equal length, but it is just for mere convenience. So, let's say this is your timeline. You are going to divide it yearly, 1, 2, 3, and then up t plus 1, and then you are going to have more interval up until k minus 1 and k. So your k is very large. Let n be the initial size of the cohort study, and k is the very large interval. And let dt be the random variable of the number of death from t to t plus 1. And you have to know that your t is in between 0 and k minus 1. Let's let nt equals to the number of survivor at time t. Random number of survivor at time t. And let nt represents the realized value of big NT, and dt represent the realized value of big dt. You also have to note that n0 should be equals to n, and nk should be equals to 0. At time 0, everyone survived, and then at time k, everyone already died. So from here we can say that n t plus 1 is actually equals to nt minus dt for any t which is equals to 0, 1, 2, and so on up until k minus 1. We can also say that qt is the conditional probability of death in between t and t plus 1. And pt is 1 minus qt. We also know that st is the unconditional probability of survival to time t, so we can say that st times qt is the unconditional probability of death between t and t plus 1. This one's also equals to t given q0. So let's look at the distributions for nt and dt. Okay, so we know that nt is binomial n and st. And we also know that d0 is depth 0 to 1, d1 is from 1 to 2, and so on. So d0, d1, d2 up until the last one would be dk minus 1 has a joint multinomial distributions with probability of dt is equals to st times with qt, which is also equals to t given q0. Okay, so we are going to use the properties of multinomial distributions. Pn for any d0, d1 up until dk minus 1 is equals to n factorial over d0 factorial times d1 factorial times with up until dk minus 1 factorial times with from t equals to 0 up until k minus 1 t given q0. This is to the power of d1. So your expected value of dt is equals to n times with t given q0. And the variance of dt here is equals to n times with t given q0 times with 1 minus t given q0. For any covariance of dr dt, this one is equals to negative n times r given q0 times with t given q0. We have to note that the mean, variance, covariance are all unconditional for this distribution. Let's continue in the next video. Thank you.